We shall now talk about arrays. Arrays is another fundamental feature which is provided in almost all modern programming languages you shall be working in your life, whether it's Python, C, C++, Java, and so on. But before we talk about arrays, let's first understand why do we require arrays or why do programming languages provide arrays. Now, let us say I tell you I want to store the roll number of 500 students. So what you can do is you can declare the first variable as int r1, second as comma r2, r3, r4, r5 until r500. So each of these variables can store the roll number of one student. Now let us say I increase the number of roll numbers I want to store to 10,000. It's not a great idea to keep typing R600, R700, R800 all the way till R10,000 because there are multiple problems with this. The first problem is your code is only going to have so many variable names. You will have pages of just declaration of variable names. Then typing them whenever you want to refer to them is another challenging aspect. So most programming languages provide a facility called as arrays. Let us understand what is an array. Let us say I want to group 5 integer data type together. So what I can do is I can declare something like this int num of 5. What this means is think of num as a box which can hold 5 numbers or 5 integers. Those 5 integers could be 2, 91, 71, 6 and 52. Unlike normal life where we start counting from 1, in programming there's a very good reason why we start counting from 0. So 2 is in the 0th position, 91 is in the first position, 71 is in the second position, 6 is in the third position, 52 is in the fourth position. Since we are counting from 0, there are a total number of 5 elements or 5 objects. These values are known as elements or objects in an this particular array. This is known as declaration of a single dimension array because it just contains one row and as many number of columns you want. Let me explain a few points associated with this particular diagram. If you see here, the memory locations on the top, these are all memory locations. After 2, immediately after 4 bytes, 91 is stored. Immediately after 4 bytes, 71 is stored. Immediately after 4 bytes, 6 is stored. So these numbers are stored one after other in a contiguous memory locations. That means sequentially in the memory. This a unique advantage why it's done. You will understand that once you learn pointers in the next year. Now, if I refer to something like this, if I say num of 3, I am referring to 6. If I say num of 2, I am referring to 71. If I say num of 5, I am referring to a location whose value cannot be guaranteed because the last location you can access is 4. So this on the top stands for the memory addresses. This stands for the values. Now if you look at this 2, 3, using this 0, 1, 2 or 3, I am able to get the values of different elements or objects of an array. This 0, 1, 2, 3, 4 are known as array subscripts or indices or indexes. So using this subscript or index or indices, I am able to get the value. You have done that in maths. Suppose you have an matrix, you say m of I, j. So here it means that matrix m, ith row, jth column. So similarly here, this are I and j are the subscripts to access the values of an array. So now what I have done is a few important things. If you look at the data type of all of these fellows, all happen to be integers. So array is a collection of elements or objects of the same data type stored sequentially one after the other in the memory location. Since integer occupies 4 bytes generally, so after 100 plus 4, 104 is 91, plus 408 is 71 value and so on all the way till 116. So grouping of related data items of the same data type is known as an array. So you can group simple data types, like you have created an array of integers, or think of it as a grouping of integers. They could be grouping of real numbers, and then you can group user defined data type called as structures. We'll deal with it once we come. Now, first, to refresh, arrays are objects or elements of the same data type. All of them of the same data type. These are all objects. 71(6). Values, memory locations, numbers, variables, constants are all known as objects. They are starting number. They are referred from 0th position on to the nth minus 1th position. Using this 0, 1, 2, 3 known as indices or subscript, we can get the value, or we can refer to that particular position. Now, to give you a better understanding, let's take one more example of representation of an array. So here what I have done is I have declared an integer array size 5 again. Let's say the name of that is a. So think of it like this. I have said int a of 5. Okay, this is int a of 5. Or let me write it here. It's a lot more clearer. Int a of 5. Okay, I have declared int a of 5, and somehow I have stored values. I'll show you how you store values a little later on. So in the 0th location there is 10, first location 20, and so on till the 4th location there is 50. So on the top row, what you see, these are all the elements, values, or objects of integer array A. 0, 1, 2, 3, 4 is known as the subscript or indices of array A. And the last row refers to the address of the 0th element. Address of 10 is 1000. Address of 20 is 1004. So if you see, there is a constant difference between the address because they are stored in sequential memory locations. Since all of them are of the same data type, I can increase the next location by the size of the original data type. So in the above thing, A is the name of the array. A of 0 refers to 10, A of 2 refers to 30, A of 4 refers to 50, A of 5, I do not know what is the value because that is out of bounds. So this is known as contiguous memory location. Now what we shall do is, let us try to understand how we go about declaring a single dimensional array. So the general syntax for declaring a single dimensional array is data type. It can be int, float, struct, double, long, char, anything, name of the array and the size. So here data type is int, marks is 10, that means size is 10 elements it can store, and array name happens to be marks. Now suppose I want to give it initial values, just like I say int I is equal to 10. I want to give some values to a single dimensional array. I want to initialize it. Let us see how that is done. So here you can take a look at it. So here what I have done is I have an array consisting 5 elements. 0th element is 9, first element is minus 5, fourth element happens to be 8 since I am counting from 0. So if you give values to each object or element when the array is first defined, these values will be stored like this. So in memory, after 9, minus 5, 6, 2 and 8. If 9 is stored at the 100th address, this will be 104, 108, 112, 116. And subscript refers to the position of each of these elements. If I say A of 2, I am referring to 6. If I say A of 0, I am referring to 9. Now, there's one thing you need to remember. Suppose I declare fewer number of elements than the actual size. Although I say size 5, but I only give initial value of 9 and I don't give anything after this. So the 0th position will get 9. All the other subscript positions will be automatically initialized with zeros. Alright, I hope that really makes it clear for you. Now let's take a look at how we go about declaring floating point or an array of real numbers or floating point numbers. So here what I have done here is I have declared a variable or an array type of variable called as WT, which can stand for weight, and the data type is float. Its size is 5. I've initialized it with only 3 values, although the size is 5. So here what happens is in the 0th location 1.5, first location 2.8, second location 2.5, third and fourth location automatically initialized with zeros because I have not given any values. So if you don't initialize it with values after giving initialization to 1 or 2, then the remaining are filled with 0. Suppose you do not initialize any of them, then all of these will be random or garbage values, unknown ones and zeros. So just be sure, if you want rest of them to be 0, at least initialize the first one. So take a look here. If an array does not get initialized, then the array elements will contain random or garbage values if you forget to, or if you don't do this particular thing. This initialization is not compulsory, it is optional. Now take a look here. Int a of 5, I'm giving it this way. This is equivalent to without specifying the size. Here the size is determined based on how many numbers you are initializing. Here I am initializing 5, also I have given size. Here I am initializing 5, the size 5 is automatically determined by the compiler. You must always use the flower bracket for initialization, and to indicate the array size you must use the square bracket. A lot of these forms the syntax of the language, and you will become familiar as we proceed to do a number of examples.